Title of case study. Case study 1, finding investment allocating using Gaussian elimination method. Case study 2, allocating funds using Cramer's rule. Case study 3, break-even analysis using Gauss-Jordan elimination. And lastly, case study 4, mixture problem solved using inverse matrix methods. Introduction to the case study. Case study 1, finding investment allocating using Gaussian elimination method. Understanding how to distribute funds wisely can be challenging when multiple conditions exist. To grasp how investments interact, one must know how to solve the system of equation accurately. These case studies go to apply the augmented matrix method and elementary row operation (ERO) to find a unique solution. Case 2, allocating funds using Cramer's rule. Solving how to invest wisely can be difficult when there are multiple constraints. To fully understand how different investments relate, one must be able to solve the systems of equation exactly. This case study's objective is to apply Cramer's rules to find the amount to invest in savings, bonds and stocks. Case 3, break-even analysis using Gauss-Jordan elimination. Managing sales targets involves balancing multiple dependent variables. Gauss-Jordan provides a clear way to calculate how many items must be sold. This case study use Gauss-Jordan to find quantities that cover fixed costs. Case 4, mixture problem solved using inverse matrix methods. Creating chemical mixtures with specific proportion can be complex with multiple constraints. The inverse matrix method allows quick solution if the system is invertible. This case study applies matrix inverses to determine the volume of each solution needed.
The purpose of the study. For case 1, the purpose of study is to find how much money should be allocated to each investment type based on condition given to solve the problem by using Gaussian elimination method. For the case 2, the purpose of our study is to determine how much the money was invested in saving account, bonds and stock market, and to solve the problem using Cramer's rule. For the case 3, our purpose of study is to determine how many of small photons, medium photons, and large photon size must Adelina sell to pay for the both and to solve the problem by using Gauss-Jordan elimination method. And lastly, for case 4, the purpose of study is to find how many liters of each 3 different acid solution should be used and to solve the problem by using inverse method. Now, we move to methodology. For the question 1 is under case 1. The question is, a startup company has received a grant of 50,000%. The management decide to invest this amount into 3 different investment vehicles, which is savings account that have 3% annual return, government bonds that have 5% annual return, and stock market that have 8% annual return. The management sets 3 conditions for this investment vehicle. The conditions are the total investment must be 50,000 and the amount invested in government bonds should be twice the amount invested in saving account. Also, the total annual return from all investments should be 3,200. How much money should be allocated to each investment? First step, we let X is equal to amount invested in savings account, Y is amount invested in government bonds, and Z is amount of invested in stock market. Step 2, from the information given into equation. We got 3 equations. The first equation is X plus Y plus Z is equal to 50,000. The second equation is Y is equal to 2x, and the last equation is 3 over 100x plus 5 over 100y and 8 over 100z is equal to 3,200 based on the equation from that into augmented matrix. Next, we need to perform the elementary row operation on that matrix until we get a row echelon matrix. The first step is to create the leading one at the first entry of row 1, which is already in place. Next, we need to zero out all the entries below this leading one. Firstly, we multiply the first row with 2 and add it to the second row. Next, multiply the first row with negative 3 over 100 and add it to the third row. Now, proceed to the second row. The first non-zero entry in the second row is not 0, so multiply the second row with 1 over 3. The entry below the leading one in the second row will be zeroed out by multiply the second row with negative 1 over 50 and adding to the third row. Proceed to the third row. Multiply the third row with 300 over 11 to get leading one at the third row. Now, the matrix is in row echelon. Convert the row echelon matrix to a system of linear equation. So, we get X plus Y plus Z is equal to 50,000. The second equation is Y plus 2 over 3Z is equal to 1,000 over 3. And the third equation is Z is equal to 310,000 over 11, which is 28,181.82. Solve the system using batch substitution. We got the final answer for amount of invested in savings account X is equal to 7,272.73, amount of invested in government bonds Y is equal to 14,545.45, and the last one is amount of invested in stock market Z is equal to 28,181.81. The solution for this system is
Next,
unique.
for methodology 2, a person invests 60,000 in 3 accounts. That is savings account with 2% return, bonds 4% return, and stock market with 7% return. The amount in bonds is 10,000 more than in savings. The total annual return is 2,700. How much is invested in each account? First, we define the variables and we like X amount in savings, Y amount in bonds, Z amount in stock market. The linear system of equation is X plus Y plus Z equals to 60,000, and next is negative X plus Y plus 0Z because there is no Z, and equals to 10,000. And next equation is 0.02x plus 0.04y plus 0.07z equals to 2,700. We let the system be A x vector equals to B, where coefficient metric A and the constant vector B, and we solve this using the Cramer's rule. And we solve the determinant A, use the formula, and we got 0.08. For determinant AX, we replace the first column with B. So after that, we use the cofactor expansion on the first row, and it became 1,200. And for determinant Y, we replace the second column with B and use the cofactor expansion on the second row, and it became 2,000. For determinant AZ, we replace the third column with B and use the cofactor expansion on the third row, and it became 1,600. To calculate the determinant for X, for X is determinant AX over determinant A, and it became 1,200 over 0.08, and it became equals to 15,000. And for Y, we use the same formula, but we replace the determinant AX to AY, and it became 2,000 over 0.08 equals to 25,000. And for Z equals to 1,600 over 0.08 equals to 20,000. So the answer is saving accounts is RM 15,000, and bonds is RM 25,000, and lastly for the stock market is RM 20,000.
Methodology Case 3. Adelina sells photograph at art fairs. She prices the photo according to the size. Small photos cost 10 ringgit, medium photos cost 15 ringgit, and large photos cost 40 ringgit. She usually sells as many small photos as medium and large photos combined. She also sells twice as many medium photos as large. A booth at the art fairs costs 300 ringgit. If her sales go as usual, how many of each size photos must she sell to pay for the booth? We let X equal to number of small photos, Y equal to number of medium photos, and Z equal to number of large photos. And then we put the statement in equations. First equation is X minus Y minus Z equal to 0, Y minus 2Z equal to 0, and last equation is 10x plus 15y plus 40z equal to 300. And then we write the equation in augmented matrix. Using Gauss-Jordan elimination methods, we use the suitable row operation to get the last matrix in RREF. And the answer we will get is x equal to 9, y equal to 6, and z equal to 3. We can conclude that the number of small photos is 9, and the number medium size photos 6, and lastly the number of large photos is 3. Methodology Case 4. A chemist has 3 different acid solutions. The first acid solution contains 10% acid, the second contains 40% acid, and the third 60% acid. The chemist wants to use all three solutions to obtain a mixture of 100 liters containing 45% acid. The supply of 40% acid is low, so twice as much 10% solutions as 40% solutions must be used. How many liters of each solution should be used? First, we let X equal to amount of 10% acid, Y equal to amount of 40% acid, Z equal to amount of 60% acid. And then we put it in the equation. Equation 1, X plus Y plus Z equal to 100. Equation 2, 1 over 10X plus 2 over 5Y plus 3 over 5Z equal to 45. And last equation is X minus 2Y equal to 0. And then we multiply equation 2 by 10 to get the whole number. And we will get X plus 4Y plus 6Z equal to 450. And then we write the new equation. And we write the equation in the augmented matrix AX equal to B. To use the inverse method, we must find the A inverse. We use the suitable elementary row operation to get the identity matrix on the left side and coefficient matrix on the right side. After we get the A inverse, we multiply it with B. And the final answer we will get X 35, Y 12.5 and Z 62.5. Then conclude that solution for 10% acid X is 25 liters, 40% acid Y 12.5 liters, and 60% acid Z is 62.5 liters.
For result and discussion, based on the purpose, we need to find how much money should be allocated to each investment type by using Gaussian elimination method. For question 1, we got the answer for the investment allocation is RM 7,272 with 73 cents for savings account, RM 14,545 with 45 cents for government bonds, and RM 28,281 with 82 cents for stock market. For next, based on the purpose, we need to find how much is invested in each account using Cramer's rule. For question 2, the answer we got is RM 15,000 for saving, RM 25,000 for bonds, and RM 20,000 for stock market. Based on the purpose, we need to find how many photos of each size she must sell to cover the cost of the booth by using the Gauss-Jordan elimination method. For question 3, the answer we got is 9 small photos priced at RM 10 each. Then 6 medium photos priced at RM 15 each, and the last one is 3 large photos priced at RM 40 each. Based on the purpose, we need to find how many liters of each solution should be used by using the inverse matrix method. For question 4, we got X equals to 25.0 liters for 10% solution, and Y equals to 12.5 liters for 40% solution, and Z equals to 62.5 liters with 60% solution.
In conclusion, we have achieved our objective by using Gaussian elimination method, Gauss-Jordan method, Cramer's rule, and inverse method. This method helps us solve systems of equations efficiently. These methods highlight the practical value of mathematics in making informed and effective decisions. Its application extends to solving linear equations in real-world scenario, making it a fundamental tool in mathematical modeling and problem solving.